Good afternoon. Welcome to the panel. This is probably one of the cooler parts of this industry because, let's be honest, we have lots of different elements in this industry that are really hard to fix. But when it comes to really hard problems, I don't think you can get anything harder than ICS, OT, or indeed IoT. It's not something that's very easily patched or fixed. And often we hear the term expert bandied around a lot in this industry, but I think in this case we've got 3 experts here in the ICS world, and I'm hoping we're going to have a really good candid discussion, put the world to right, hopefully not annoy any vendors, and fix stuff. So I want to introduce Cassie first and tell everybody how cool you are.
All right. Hi, I'm Cassie Crossley. I'm a Vice President for Supply Chain Security at Schneider Electric, and I'm also a Product Security Officer. You may know us by our brands such as APC and Square D, Aviva, but we're definitely in the ICS industrial control space, critical infrastructure. And so I work with customers and suppliers, and specifically a lot on product security, assessments, and risk management. And also the author with an O'Reilly book of software supply chain security.
Thanks, Cassie. Thomas.
Thank you. Good afternoon, guys. Hope you have a good time. So my name is Thomas. I'm a professor for cybersecurity at St. Pölten University in Austria and founder of Limas Security, boutique OT security consulting company. My background has been OT security now for 20 years. I was the lucky or unlucky guy responsible for product security at Siemens when Stuxnet hit. It was really a great and interesting time. I'm also the founder of their product cert. Yeah, has been an interesting career path.
Thanks, Thomas. And Noam.
My name is Noam. I'm part of Clarity Team 82. At Clarity, we do CPS, cybersecurity and protection. And specifically, my job at Clarity Team 82 is basically vulnerability research, where our job is to look at different OT and IoT devices, find vulnerabilities, and responsibly disclose them to the vendors. And that's exactly what we do with a few hundred vulnerabilities each year in the last few years.
Thanks all. So I'm going to start off with a really easy question, and any of the panelists can jump in here. Is ICS OT actually complex, or is it just because it's really hard to do anything and move quickly? Anybody can pick that one.
Let me jump on that, Daniel. So I think it is complex, and I enjoy its being complex. I think if it weren't for OT being quite complex, heterogeneous environments, not just the components, but actually the solutions in all kinds of different sectors, probably I wouldn't be in cybersecurity anymore. So I really enjoy the complexities and peculiarities of all those OT controls and elements. Yeah, definitely.
Cassie, I know you've got a lot to add here on the supply chain.
I definitely think it's complex but simple in 2 different ways. When you're bringing the system together, it's complex, of course. When you're working at just a specific level, it's really interesting, and you're really looking at it from just a central point. You've got a mission for that product. It can get its job done. So I love that part of it because it's part of a bigger picture in all cases. What's also complex about it is I'm sure those that have worked in industrial control systems, when you said heterogeneous, it's also homogeneous. People want to buy the same product because they've used that product for 10 years and they have 400 of them, and so they keep buying those, even though there's improved generations of those products, which make it more interesting from a security standpoint. Also, most of the operational technologies were not intended for internet connection. So you've got so many different layers that we're having to consider that we've seen in the IT world and in the software and application worlds that's very different, and people don't understand it from a firmware aspect.
Agreed, thanks. So, all right, we're going to agree it is complex. My background is out of bug hunting, bug research, exploit dev. Noam, very similar. Can we maybe agree that the bugs are the same bugs that everybody else is facing? They're just harder to get access to?
Exactly. And usually in OT, when we're talking about bugs, we're always saying that the OT is behind in terms of security. Yep. And I think one of the reasons that this is actually the case is because we see moving from actual physical serial connections where you need to have physical access and basically touch each device, to putting them in an IP network, and in some cases even the exposed network of the internet. And that's why we usually see a lot of different obvious or low-level, low-hanging fruits bugs. And this is what makes OT so complex. The fact that this basically connects the physical realm of actual physical process and the cyber realm of actual computers and programs that are running basically inside a CPU somewhere.
Okay. So the bugs are sexier. We've got complexity. The one thing that I think we all share the pain of is, one, nobody knows what they have. So asset inventory is our Achilles heel as this industry. And two, the vulnerabilities, understanding where the vulnerabilities are and how to patch them. And that becomes more complex, as you mentioned, Cassie, with the fact that let's just put a networking stack on it and connect it to the internet. What's the worst that could happen? And then supply chain. Are we in a position where we're getting better at doing that? Or is OT still decades behind the rest of, say, enterprise and SMEs?
Well, I think different companies, organizations are at different stages. I do know some customers that are very good with their asset management at the OT level. However, they don't have their firmware versions. And so you're sort of lacking, yeah, I know I have 100 of these, but they could all be on this original firmware that came off the line of that. So we have a long way to go. As anybody who's worked with a lot of these products, you can't and safely do just normal agent kind of detection. You don't want to risk, especially if it's any kind of safety process. So it's a lot of manual activity, a lot of crawling under things. It's extremely difficult, but yet visibility is very important. And I work a lot and provide SBOMs to our customers and ask them which version, and they're always apologizing because either they don't know the version or it's like 10 years old, whatever it is. And I'm like, I just need to know the version. It's okay. I'm not going to judge you. So it's a long way to go from that asset management. But I see that in the IoT space. They're not inventorying printers and every single IoT device either. So we just don't have effective controls and activity in place because it's so time consuming.
Cassie, getting printers to work is hard enough. We don't bother updating, right? Just leave them be in the corner. Thomas, I want to touch upon the mitigation side. It's easy to say that OT is really insecure and ICS is insecure. How easy is it to mitigate these threats and harden it, given how standardized the industry is?
That would depend a little bit on the industry that you're actually looking at, coming back to the solutions being quite heterogeneous. I mean, as Cassie was saying, first of all, it would come back to, if you look at the operator perspective, do you have asset inventory, right? That coming back to the solution provider, would they have provided a software bill of material as part of the solution, which they at some point were handing over? Luckily, lots of the, let's say, really strong vendors in the market have had their own software bill of materials getting collected, like a capability ramped up, and this is definitely what we need, which is pretty much like the baseline for doing any updating for vulnerability-related causes. And here's the thing, even if you know that there is a vulnerability, you may not yet be able to actually fix the thing because there's operational constraints. Like if you take, for instance, an electrical substation, it might need to run for a year, 2 years, maybe 3 years in a row until there is an actual maintenance window. So there's a practical thing associated. Which means, of course, we should do our homework as OT security guys, both vendors as well as operators, but there are some constraints that make it more difficult to follow up with actually closing those vulnerabilities that we know are out there.
Yep. I'm going to touch upon your point of the power grid. So, Noam, Clarity have been doing some amazing research in that space. With, say, the power grid, which is somewhat sensitive, right? We don't want it to break. We have high levels of standardization. There's control processes, there's everything. But if we take, say, OPC, it's not always being done properly. And indeed, Clarity itself have found a lot of vulnerabilities. In your experience doing the kind of bug hunting, bug research, red teaming, where do you see the difference between what Thomas is saying and what you're actually seeing when you're doing these tests?
So we do see a very wide variety between different products and product lines. I mean, if we're talking about a standardized industry, like let's say power grid electricity and power generation, we do see this industry as being way more regulated. Now, this is not very common and a commonplace in OT, and we do see many times that different protocols, different lineups, different devices are not as regulated, and it's more up to the vendor to do whatever they choose to, and basically to implement things as they see fit. Now, specifically in OPC, while there is a very, very good RFC, it is still up to the vendors to interpret different operations and different procedures, and because of that, we do see some bugs. And while we did find in the past what we call protocol level bugs, which is basically a bug that could affect every implementation of the OPC UA protocol, we do see a lot of vendor-specific bugs or SDK-specific bugs, which could affect maybe thousands of different devices. However, it is a problem of implementation. Now, I do believe that this industry should be more standardized and these protocols should be more standardized and be less for the developer to interpret this as their own, but instead be more like you should do this and that, and this is up to exactly what you need to be available through the standard.
Taking on that point, Cassie, I want to talk about package units, right? I want to build something and I don't have the capabilities. I go to a vendor and buy a fully functioning packaged unit, right? Which is great. Often we don't see security as part of the standard package. And that leads into situations where if something does happen, you have a weird legal gray zone of who's actually responsible. Is it the vendor? Is it the package supplier? Who does what? In your experience in the whole supply chain, as we're learning more and more, the supply chain is a somewhat minefield. Where are we at the moment and what needs to change there?
Well, it's definitely a shared responsibility model. Just as we use in the cloud discussions, we consider it, there's secure by design, building secure by default products now, we've seen that, but also secure deployment and what we like to call it Schneider Secure Operations, which could be the asset owner, but often is a third party for those asset owners. And we're seeing in Europe with NIS2, and then we see with NERC-CIP, there's a lot of responsibility. I mean, if you even look at the NERC-CIP rules and what they're required to do from a supplier aspect, I like to remind people that Schneider Electric itself, we're not regulated. The products that they're putting into the environment and those ownership are the regulations. That's where NERC-CIP, they have to do the proper due diligence. They have to make sure that their operations, they're the ones that get audited, not the actual manufacturer, which, you know, we have the secure by design and we are an ISA IEC 62443 shop, you know, secure development lifecycle, maturity level 4. That's very important. But then we also need to be working with all of our partners, our own services, other services around to make sure, as Department of Energy likes has really put together the cyber-informed engineering, making sure you understand the entire life cycle. So that's why it's a shared responsibility in our view.
So that seems to me, at least, that's one case where ICS might be a little bit more mature than the outside industry in that, you know, we've been talking about supply chain for a good couple of years now. The reality is we still don't know what we have on the asset aspect, let alone what's building up. And that leads me to think that, and I hate to say this as the hacker here, maybe we do need more oversight from government and government bodies in both parts of the industry, because the reality is we as an industry have not been very good at doing this, and attackers are exploiting this at scale. I know this is a hot potato. I'm going to give all three of you a chance. Do you think we need more oversight from government, as we have with ICS, in the, I don't want to say normal, but the other side of the pond? No.
So, as you said, this is a hot potato, because no one ever wants to say that the government needs to be more oversighting and be more controlling of different industries. However, while we do see that some regulations are being passed in regards to government oversight in specific fields, we do see an increase in security level in these fields. And it does somewhat correlate to the actual requirement of different companies. Now, when we're talking about OT, we're talking about critical infrastructure. And I mean, at the end of the day, if your water facilities or your power grid gets hacked, this has very, very bad physical consequences. Yep. It could endanger thousands, millions, basically everyone who uses this infrastructure. Now, I do believe that some regulation should be done to make sure that we at least reach a standardized level, a minimum required level to be able to protect it. And we do see some opportunistic hackers. It could be an APT, nation state, you name it, that do target critical infrastructure and basically the lower level of critical infrastructure that are less protected, less regulated, and less security specific.
Okay, good. Right, I'm keeping score. So 1-0 to government oversight here. Thomas.
Well, to your question, Daniel, I would say, at least in Europe, it's pretty clear the governance of the European Union believe that oversight is necessary. If you look at what we have coming up, I mean, Cassie mentioned over here, you guys have had under XIP for, what is it, nearly 20 years around, at least for operators. In Europe, we do get NIS2, so incident reporting obligation, hefty fines if you don't report for the operators, and we do have the Cyber Resilience Act upcoming that would go to the suppliers, and I mean, it's still a draft, it's not finalized. It's also more aiming in general at cyber physical systems, more IoT, so it's not so well designed yet for industrial solution, but we will get something like that in the European Union, and with that, the answer is, if government thinks it's necessary, it will be necessary.
Okay, 2-0, we're coming up to a hat trick.
Yeah. So I believe in market driving forces, one of which can be, for example, government procurement. U.S. government is one of the largest purchasers, so by being able to require software attestation forms and things, I don't consider that as much as a regulation. If you want to play in that field, you need to pay and get certifications and do the due diligence. So I do like the up-leveling, but we have to remember that a lot of our products are commercial off the shelf. So I get asked, you know, does this comply with DoD, whatever? Well, when we built the product, that didn't even exist, yep, let alone, you know, all of these other requirements. So for example, the Cyber Resilience Act, the CRA, it has certain conditions that if we have a product that is mature again, especially in the OT space, that has been on the market for 15 years, it didn't have some of those secure attestation pieces. I don't have the provenance that you would see in today's technologies. But also from being able to bring this to the concept of commercial off the shelf, I can sell a PLC in, you know, in critical infrastructure. I can sell it in manufacturing. It's the same PLC, right? So which, you know, this piece is regulated. It's not like a medical device where I know this is my intended. The use case is very broad. And that makes it more difficult for those of us that are building products that have that flexibility in that area. So it's hard to regulate, which is one of the reasons why the OT piece, it's like, well, by itself, it can only do this, but it's usually intended as part of a system. And that's why we've had so many discussions on that. So I think I'll just say, I like there to be a market to drive those incentives, and I see that need, but I don't expect everything to be regulated. We are in all 16 sectors of the U.S. Critical, you know, all the critical infrastructure pieces. We sell to all 16. You know, it's hard to regulate something when you sell to every single sector.
Okay. I'm going to give you a point for that in the opposites and 2-1, so that's pretty handy. I do want to explore the safety side for Thomas. So in heavily safety-oriented industries, oil and gas, right, the safety should always be first, not third. When you move over to manufacturing, it's not as important. It's more business focus. Is there a major way, a major difference in how you mitigate risk for both of those? Or is it that the safety industry has to be secure because blowing people up is not seen as cool, whereas if you were in manufacturing, you could potentially be a little bit more lax on the safety security element?
So I think the major difference for that is that in industries which have been heavily regulated from a safety point of view, the amount of effort that goes into safety engineering, like which type of safety integrity level would your system need to fulfill, for instance, is like much larger. And there's like lots of formal procedures, HACCPs, PHAs, and things like proven methodologies taken out or carried out by safety engineers to bring down those hazards, those risks, at least for those industries. So the amount of safety engineering, if I may summarize it that way, in classic manufacturing is just considerably smaller.
Okay. All right, I'm going to change it up a bit now. So we're at Black Hat. There is a big, has anybody been down to the vendor hall yet? Just show of hands. Quite a few. How many of you saw any form of product for ICS, OT, IoT security? Okay, so it's not bad. What is the current state of play when it comes to security for that space? Like, are we in a better place at the moment with all the technologies? I'm going to touch on AI in a minute. Don't groan. But are we in a better space where we were, say, 10 years ago? Or is it still fairly slow to everything else?
Well, I'll start with this one. I would, again, talk back about the people would prefer to keep this sort of comfortable what they've been purchasing. So there's definitely a lot of advancements, and we're able to do so much more in being able to provide products. However, in order to have interoperability and backwards compatibility, and that's where the secure by default comes in, we're still being asked for, TLS 1.0, right? So there are, environments where you're operating with all of this equipment. So I do think there's advances, but we do not expect those that are procuring to be able to retrofit and modernize their entire, landscape of what they have. So while there is movement ahead, and we're seeing this, with especially some of the requirements. MFA, well, how do you do MFA for a device underneath? There's zero trust architecture, and so there is quite a bit to go, but there are also those requirements being built in. So I am not seeing from the customer side, so all of those out there, ask for those features, and not just the standard IT sheet. I mean, really OT security features, how are you going to do that as part of your plan? Because the more that you ask for, certification of a product under 3-3 or 4-2 or whatever for the 62443, the more it'll push the industry to add improvements and security features. And that's what's really important. But we need to hear it from our customers.
Okay. I'm glad you mentioned the customer thing. In 2017, Halvor Lake did an amazing keynote at Black Hat Asia. And I elaborated on that when I did my keynote for London, the fact that we're not building a secure, defendable internet. And it's because we don't ask for these features, right? So I want to pivot that a little bit for Noam right now. Have you seen a big change in people tearing stuff apart, as in the security research industry and the mindset? And I'm thinking of a vendor here, I'm not going to mention the name, who traditionally wasn't the best when it came to security, but is getting better, is more responsive to research, is more responsive to people tearing apart their products and trying to make it better. Have you seen a big difference when you report a vulnerability to how ICS OT companies now talk to you, or is it much of the same?
Yeah, so I can speak as a vulnerability researcher, and we do see a huge shift. Because if we're talking about in the past, when you approached a vendor and told him, hey, I found these critical vulnerabilities, it could affect a whole fleet of devices, all the versions, you name it. Many times in the past, the industry was afraid. Basically, they pushed back.
Yep.
And they were not basically the best partners to fix them. They were suspicious, they were not sure where do security researcher and vulnerability researcher were coming from, what is their approach, maybe there is some kind of hidden agenda.
I mean, you look dodgy, right? I wouldn't take a report.
For sure.
So yeah. Totally.
However, like now we do see that the vendors realize it.
Yeah.
And now when you approach, this is the big vendors, it still exists in some smaller vendors that were not approached in the past. by security researchers that all they wanted to do was help and improve the security and basically the attack surface on their devices. However, the big vendors for sure, because we do see them moving to a more secure development. We do see them implement all of these new security mechanisms. It could be mutual trust, TLS, all of this movement from hard-coded keys, from hard-coded passwords. We do see the vendors being more security in mind, meaning from the get-go, are building their devices and their ecosystem more secure, and being more proactive and helpful with researchers that are coming to them and telling them, hey, we identified this critical vulnerability. They do give you full support.
Okay, that's positive. I'm going to have to go there, Thomas. AI will change everything in OT, right? I mean, it has to naturally because it's changing everything else. I'm out of a job now, according to some research. So are we seeing a disruption in the space with AI?
I'm not convinced that AI will make things better, especially in control system environments. I have to tie that a little bit into your former question because, you know, we're seeing, at least with operators, that many of them are still lacking like certain skills to detect. I wouldn't even call it anomalies, just problems in their environments. So throwing in a super sophisticated AI type of service or component, some of them I would think would get overwhelmed at this point. You know, making things better, I would rather love to see at every operator where we show up to see something like, yes, we have an asset inventory that matches actually the environment, that has standardized procurement guidelines for every solution, makes it also easier for the vendor, instead of going for the next product promising magic capabilities with AI. Sorry for the rant.
Cassie, your thoughts?
So I can't speak as much on the operational side from an internal development, creation, and maintenance. So for example, our PKI certificates for firmware, 30 years, right? So think about the number of patches and updates overall, and when you are moving on to next generation of products, being able to do all the test suites, and especially in the world of where we used to be able to just fix bugs, now you have to spend such an enormous amount of time remediating for vulnerabilities, updating libraries. We used to not, of course, in our world as software developers, never had to really update libraries, right? It didn't matter. Worked that one time, we tested it, so on and so forth. And that's not the world we live in now. So I see the AI technologies, and I meet with startups and all the time, and I'm seeing the improvement really quick to be able to enable the development teams and the maintenance of it for the improvement, because especially in an OT world, like we've already qualified that on that chipset and that environment, which is, from a software standpoint, you don't have those challenges from a system. If you're doing interoperability testing, it could take 6 months to do proper interoperability and regression testing. And being able to use AI technologies in the future that can better create test scripts, test suites, be able to say, okay, here's the whole flow through. So I do see it, especially when you're shifting left and bringing this into the secure development suite, helping a lot in the future.
Good. Okay, so we're in two minds here. It could be really useful. We're at Black Hat, and I want to stop talking about attackers because that's why we're here. It's quite clear that ICS is the pretty girl guy at the dance at the moment, and there's lots of adversaries who fancy a go. Where do you see in the next 5 years the vulnerabilities and attacks happening? And this is your chance to either be proved really wrong when people watch this YouTube video in 5 years' time, or proved right. So I'm going to start with you, Noam.
So I believe that currently the biggest attack surface that basically exposes a lot of companies and organizations is the hidden devices. At the end of the day, when we're talking about an OT environment, we usually forget that it is full of different devices that are not specifically OT, but could be more in the IoT realm, that could introduce huge risk to these networks. It could be sensors that monitor and do preventive maintenance. It could be different devices that maybe connect you as a router and gateway to the internet.
I was going to say, we love putting stuff on the internet.
Exactly.
Right? And we're not very good at that, even in the traditional space. So,
well, at the end of the day, when a company has tons and tons of remote sites, somehow all of these remote sites need to be able to reconnect to a centralized management solution. And to do so, we must somehow connect these remote sites basically to this main unit.
Okay.
Now, this introduces huge risk because then we are in a risk of exposing our internal sensitive networks inside these sites to the internet and possibly to attackers. However, when we are introducing these IoT devices or IIoT devices, usually they come with hidden functionality and could have, for example, some kind of cloud connectivity features, which always introduce risks and potential risks to our network. Now, without good asset management and without knowing these are what we have inside our networks, all of these small devices, small unmanaged devices, we would never be able to basically protect and build walls against attacks such as this.
All right, so your prediction is the fact that we still don't know what the device does, its functionality, and the fact that we're putting on the internet is going to be more of an issue.
Exactly.
Cool. All right. Thomas, good. You can get really creative here. It's not like anybody will be watching this on YouTube in years to come.
All right, so I think that what we see partly today, especially in OT, living off the land type of threats are definitely happening or going to happen in like 5 years from now. As Cassie said, I mean, like solution gets deployed, gets commissioned, and yeah, the engineers and through this also the attacker. For both groups, it makes sense to use what is there, not just talking about the Windows or other commercial off-the-shelf operating system, but the actual tools like maybe ICS-specific protocols or toolkits. So this is surely going to stay. Maybe in combination with more specialized attack components. Some of them have been the last 1.5 to 2 years made public for Modbus, for OPC UA. So this is probably something to continue. I think there's also more research going into, let's say, the hardware details. Like researchers started to look more into the PLC back panels where you can connect multiple I/O modules, what's going in there. So similar to what you had in the earlier times, the Xbox going on between the chips. And also remember, there is like, speaking again about living off the land, I think there was an interesting publication from Georgia Tech where they tried to do a proof of concept with web-based malware, trying to jump from the web to an internet connected host, from there to an OT DMC, and then to a PLC which had a web interface. So no fancy OT protocols, just regular HTTP type of attack. So I found this quite creative. So this is maybe something to stay as well.
Okay, so the rise of lull bins, and nobody's going to be doing any form of EDR for PLC bypasses in the next couple of years.
We'll see.
All right, cool. Cassie, your prediction?
Yeah, sorry, Thomas stole almost all my points, but I wanted to also mention just that we're moving to more of a connected environments, edge devices and such. So it's very easy to see that they're going to target, of course, network appliances, right? Well, now, they see the edge devices, all of that out there, and they're using it, to be able to enter. But also, what used to be just more of a secret society, because only those that knew how to program in OT, now I'm going to generate this script. So we've got script kiddies that can be done on OT that weren't done. So they're going to be able to leverage that. I don't see, except for an expansion of what we're seeing right now, 5 years from now, it's just going to be more prolific.
Yep.
And what they're going to do and already doing from a critical infrastructure standpoint, especially let's take water utilities in the US, there's over 3,600 of them individual. They're not going to be able to put up the defenses that are necessary to be able to prevent all of these happening. So 5 years from now, it's going to be, a lot of these smaller groups being attacked by, somebody, a 16-year-old, from somewhere else, and they're going to be able to ransomware or do whatever. And I think we're going to see that every day in the news rather than just every week or month.
And I think that's where, at least in my experience, I see the advancements of large language models helping the adversary in this case, because you're right. You've always been a very secret club with a really big doorman, right? Mm-hmm. That doorman's gone on a coffee break. Now anybody can understand what a PLC is, how to program it, and all the weakness. Right. And it's either going to elevate the fact you can have loads of new engineers coming in saying we can harden this, or it just makes life easier for the adversary. On that note, we have 4 minutes. I'm sure there's lots of questions. So I want to open up to the floor. Has anybody got any questions? There are mics walking around. You've got 3 questions. Any absurd questions for these 3 fine experts?
I see a couple coming up.
I think there's one here.
Hi, my name is Louis. I just entered the ICS industry, and I have a lot of companies who are like, okay, we want to start on building our ICS security, but maybe could you give me like each one a point, like this is your first to do your 101 on ICS security. You don't have any tools, you don't have any insights. There's a jungle that has been growing there for years, and now you want to start tackling in it.
What an epic question, actually. And you want to plant. That was a really good question.
So I would say the first step in ICS security is building an asset inventory, because you can never protect what you don't know is there. And to do so, you must be able to somehow know what's in your network, what is running behind the scenes. It could be even versions and things you need to do. However, you need to know what is in your networks in order to be able to protect it. So I would say the first step is definitely being able to understand what you have running inside the networks.
I would say put the NIST SP882 under your pillow when you go to bed, right? Decent sleeping lecture. But other than that, go find either some free or commercial training courses that kickstart you into OT security. As Daniel was saying, there's lots and lots of knowledge which used to be a bit of a secret society, but is now well available.
Right. And I should go first next time because so on those, for example, Singapore has a whole OT security piece that they're doing, and we're doing globally, different countries are doing it as part of university courses and bringing it into technical institutes also. And CISA has free ICS training. And there's definitely some CISA publications that we've worked on that out of the JCDC that have talked about OT security. So at a basic, there is enough information out there to get started on some of the basics. And so I recommend some of those.
All right.
Great question. Thank
All
you.
right. Thank you.
There's a question right there.
Hello. So I have 2 questions, if that's okay. But the first one would be, how do we balance legacy systems or legacy items versus upgrading them? And I feel like there's pros and cons with, legacy hardware, software, firmware versus, hardware and firmware versus upgrading them and then them being more vulnerable.
I'll go first this time. From a standpoint of, that's exactly the risk management discussion, is you need to evaluate, of course you can do something like a Purdue model. You're looking at your threat landscape, your exterior defenses, those kinds of things, your crown jewels, those are where you need to prioritize. From a modernization standpoint, there are lots of companies out there and firms that can really be able to do a lot of that work for you to be able to determine what's the most cost-effective measure. Something that's steady state running, it's well defended, has perimeter defenses, and all of those, putting the money and the finances into that is not the same. And there is actually ability to be able to take that, and they'll do it as part of an OpEx model, so you're not having to spend CapEx. So that's something to look at.
I've got to be very careful with timing here. The AV team have weapons, and they said they will use them. We are out of time, so what I want to do is move the questions offline, if that's okay. But I want to thank all 3, Noam, Thomas, and Cassie. Thank you very much. Thanks for coming.
Thank you.